Hello everyone, this is Shankar. In this video, we will discuss control systems questions given in recent GATE 2024 exam from EC paper, Electronics and Communication paper. Now let us go into the video. The first question given in the exam is 1 mark question MCQ. In the context of Bode magnitude plots, 40 dB per decade is same as. It is a straight question, no need of any explanation. But if you just recollect, in the decade scale, 20 dB per decade is equivalent of 6 dB per octave. 40 dB per decade is equivalent of 12 dB per octave. Therefore, option B is the correct answer for the question. Now, let us look into the next question. This is also 1 mark question. It is an easy question, but there is a slight twist in the problem. In the feedback control system shown in the figure below, forward transfer function g of s is given, that is 1 by s into s plus 1 into s plus 2. Notation is same, r of s, y of s and e of s are the Laplace transform of input, output and error function respectively. Now if the input r of t is unit step function, then which option is correct? By seeing the options, it is asking about steady state error. Now in this case, even though it is a type 1 system given step input, let us check one condition. Steady state error definition is applicable only for stable systems. For marginally stable system and unstable systems, final value theorem cannot be applied, hence you cannot determine stability. So what we will do, first let us find out what is the characteristic equation. So that is 1 plus g of s is equal to 0. So what is that? 1 plus 1 by s into s square plus 3s plus 2 is equal to 0. Now s cube plus 3s square plus 2s plus 1 is equal to 0. Now for this particular characteristic equation, you can easily find out that roots are, there will be 3 roots. Roots are at, one root is at -3 and remaining 2 roots are at plus or minus j root 2. That means there is a root pair located on j omega axis. Therefore, the system is marginally stable. For marginally stable systems, the response will be, step response will be oscillatory. For oscillatory systems, steady state error does not exist, or you cannot define steady state error. Therefore, for this question, option C is the correct answer. Now let us look into next problem. This question was given for 2 marks as an MCQ. A satellite altitude control system as shown below has a plant with transfer function g of s is equal to 1 by s square. So this is the plant with a compensator. Now compensator is given here, okay. Transfer function for compensator is k into s plus alpha divided by s plus 4, where k and alpha are positive real constants. In order for the closed loop system to have poles at -1 plus or minus j root 3, what is the value of alpha? You have to find alpha value. So what I can do now, first with the given plant and transfer function, let us find out characteristic equation. Characteristic equation is 1 plus C of S into G of S is equal to 0. You can also have one more observation. The plant is given type 2, okay, type 2 plant. Type 2 plant means the poles of the closed loop poles will be at j omega axis. That means the system is at marginally stable system. Therefore, for the system to be stable, or in order to stabilize the system, we must use lead compensator. Then only the root locus diagram will be pulled into left hand side of the S plane. Therefore, you can say that C of S must be lead compensator. Lead compensator means alpha should be less than 4. Even all options are given in the same way. Now let us try to find out. Okay, so 1 plus characteristic equation 1 plus C of S is K into S plus alpha divided by S plus 4. This is a compensator multiplied with 1 by S square is equal to 0. Now from this equation you can simplify S cube plus 4S square plus K into S plus K alpha is equal to 0. S cube plus 4S square plus Ks plus K alpha is equal to 0. Now let us call this equation as 1. Now by observing this characteristic equation, you can immediately understand it is a third order equation. Therefore, there must be 3 poles. But in the question statement, what is given after compensator, the required pole location only 2 poles are given, that is -1 plus or minus j root 3. That is a complex pole pair is given, or you can also understand that can be dominant pole. So real and imaginary pole location, if you draw this pole plot, this is a -1 plus j root 3 minus j root 3. Now we don't know where is the third pole is located. Then what I can do, hypothetically let us assume that third pole is placed at -a position. Therefore, with this required pole location, now I can define required characteristic equation. Required characteristic equation is S plus A multiplied with the given complex pole location, I can write it as S plus 1 whole square plus root 3 whole square is equal to 0. Then it will give you S plus A multiplied with S square plus 2S plus 1 plus 3 will give you 4 is equal to 0. Now let us multiply S cube plus 2S square plus 4S plus AS square plus 2AS plus 4A is equal to 0. Or you can also write it as S cube plus 2 plus A into S square plus 4 plus 2A multiplied with S plus 4A is equal to 0. Now this is the characteristic equation as per the pole location, as per the required pole location. Then what you can do, by comparing equations 1 and 2, you will get, now start with S square coefficient. So if you take S square coefficient here, S square coefficient in equation 1 is 4, in equation 2 is 2 plus A, then it will give you A is equal to 2, 4 minus 2. Next, by comparing S power 1 coefficients, in equation number 1, that is k, in equation number 2, that is 4 plus a. Okay, that is a 4 plus, I am sorry, 2a. Therefore, you will get k value is equal to simply 8. Now, if you compare constant terms, in equation number 1, constant is k into alpha, In equation number 2, constant is 4 into a. Therefore, k value we got 8 into alpha is equal to 4 into a value is 2. Then the answer will be 8 by 8, that is 1. So, with this calculation, the correct answer for the given question is option D. It is simply 1. Now, let us go to another problem. This is the question number 4, or question number 4 in our video. In the exam, the question number is something else. Now, consider a unity negative feedback control system with forward path gain g of s is equal to k by s plus 1 into s plus 2 into s plus 3 as shown in the figure. Now, the impulse response of the closed loop system decays faster than e power minus t. What do you mean by that? So, in case of the response should be faster than e power minus t means, what is the basic requirement? The dominant poles of the system should be less than minus 1, okay, or left hand side of this minus 1 point. So, anywhere the dominant poles can be located left side of this minus 1. So, in order to check that, you have to find out relative stability concept. So, what I can write down here, dominant poles should be left side of minus 1. In order to find out that, in the characteristic equation, you should replace s with some other variable, let us say that is z minus 1 is equal to 0. Now, for this new equation, you apply Routh's method, Routh's table, and then find out the condition for stability in the new variable. Let us see that. Now, here 1 plus g of s is given as k by s plus 1 into s plus 2 into s plus 3. Now, here replace s with z minus 1. Then what you can write down here, 1 plus k divided by z into z plus 1 into z plus 2 is equal to 0. So, with this, you will have characteristic equation as z cube plus 3z square plus 2z plus k is equal to 0. Now, for this particular new characteristic equation, if you define Routh's table, the row corresponds to z cube 1 and 2, z square 3 and k, z power 1 element 6 minus k divided by 3, z power 0 element, that is k. So, for a new system in z variable to be stable, in other words, for the characteristic equation in z variable, roots to be in the left hand side, what is the condition here? K should be greater than 0 and 6k minus should be greater than 0. In other words, k should be less than 6. Therefore, you can define the range for k will be 0 less than k less than 6. In that case, characteristic equation for the new variable should be left side of its reference, or else characteristic equation for the original equation roots will be in the left side of -1. Therefore, from the given options, you can select option C, that is in the range of 1 to 5. It is satisfying 0 less than k less than 6. Okay, therefore, for this question, option C is the correct answer. Next one, there is a one state space model is given, MSQ. Here there is two answers correct. Consider a system S is represented in a state space form as some state space equation is given. So as per this state space notation, this is matrix A, this is B, and this is a C. Now, which of the state space representations given below has or have the same transfer functions as that of S? So what I can do now, I would see, this is a somewhat lengthy question. For the given system, I would like to find what is the transfer function. Okay, so for given system, what is the transfer function? G of S is equal to C multiplied with Si minus A inverse into B. Therefore, first I would like to find the matrix for Si minus A, that is S 0 0 and S minus A matrix 0 minus 2 1 and minus 3. So it will give you S minus 0, it is simply S, 0 minus of minus, so 2, 0 minus 1 minus 1, and it is S plus 3. So this is a Si minus A matrix. Next one, Si minus A inverse. So what is that? 1 by now AD minus BC. Therefore, S square plus 3S plus 2. This is a determinant, denominator determinant. Now let us write down adjoint. S plus 3, interchange the diagonal elements, change the sign of for off diagonal elements. Minus 2, 1 and S. Okay. So this is Si minus A inverse matrix. Now C into Si minus A inverse into B. So C matrix is 2 minus 5, Si minus A inverse S plus 3 minus 2 1 and S. B matrix is 1 and 0. Denominator S square plus 3S plus 2. Therefore, how can we further simplify? 1 by S square plus 3S plus 2, and C matrix is just like this, 2 and minus 5. So here S plus 3 multiplied with 1, that is S plus 3 minus 2 into 0, 0. Therefore, you will have S plus 3. Okay, 2 by 2 matrix is multiplying with the 2 by 1 matrix. So the new order will be 2 by 1. Now 1 into 1 1 plus S into 0, that is 0. Therefore, it will be 1. Now the last step is transfer function for the given system. It is, if you multiply here 2S plus 6 minus 5, therefore you will get 2S plus 1 divided by S square plus 3S plus 2. S square plus 3S plus 2. Okay. Now what I did here, for all of these 4 options, I calculated a transfer function by following the same procedure. If you have any new method or any simplified way to determine transfer function for the remaining systems, you please give me in the comment box. But I did transfer function for all of these cases. Out of that, I figured out for the two options, transfer function is matching with the given system transfer function. Now, transfer function, I will write down here answers. Transfer function for option A. Transfer function for option A, g of s is equal to, I got it, 2s plus 2 divided by s square plus 3s plus 2. Surprisingly, the examiner has given for the four options, determinant is the same, denominator is the same. Next, for option B, g of s is equal to 4 divided by s square plus 3s plus 2, and I found for option C and D, transfer function is 2s plus 1 divided by s square plus 3s plus 2, s square plus 3s plus 2. Now, if you observe closely, for option A and C, system matrix A is the same, but on option C, transfer function matches with the given system transfer function. For option B and D, again system matrix A is the same, but only for option D, transfer function is same as with given system transfer function. Therefore, for this question, answer will be C and D. Because of MSQ, multiple select questions, one or more than one options will be correct for the given question. Therefore, C and D are correct. So, these are the questions given in GATE exam EC paper from control systems subject. So, with this, I would like to say thank you for watching. I am Shankar. I am working as faculty at Home Institute, Hyderabad. We will offer coachings for GATE and various assistant engineer exams in the state board or national level exams, PSUs. If you are interested, you can call to the number given in the screen, or you can visit our website homeinstitute.com. With this, I will conclude. If you not yet subscribed my channel, please subscribe, and then you will get a notification whenever I am uploading any video. You can share this knowledge to your friends as well, just for educational purpose. Okay, in my YouTube channel, I am promising you, I will upload purely educational videos. Okay, after some time, I will also plan, once this PYQ is completed, I will also plan to upload some motivational or preparation strategy videos also. Thank you for watching. Hello everyone. In this video, I would like to discuss the solutions for control systems questions given in recent GATE 2024 electrical paper. Now let us go into the video. The first question is, by the way, from this subject, total 9 marks came in the GATE exam. Now first question, consider the standard second order system of the form omega n square divided by s square plus 2 zeta omega n s plus omega n square, with the poles p and p star having negative real parts, that is shown in the figure. The pole locations are given here. Now what is the question? Now consider two such second order systems defined below. System 1, it is having omega is equal to 3 radian per second, and theta, where angle theta is also given in this figure. So by seeing the options, it is asking about what is the value of the settling times. Therefore, for this system, what I can calculate, when theta is given, damping ratio is equal to, so simply I can say damping ratio is equal to cos theta. Therefore, here cos theta will be 1 by 2. Damping ratio is 1 by 2. So in this system 1, you will get quickly damping ratio is equal to 1 by 2. Next, for system 2, we will get damping ratio is cos 70 degree. Cos 70 degree numerical value is 0.342. Now, what is a settling time formula? Here it is not mentioned that 2% or 5% tolerance limit. Now, just for more accuracy, let us consider 2% tolerance. So, that will give you 4 by zeta omega n. Therefore, by using this formula, for system 1, we will get, let us say, TS1, that is 4 divided by zeta value is 0.5, omega n is given 3 radian per second. Then for system 1, this numerical value, it will be 2.67 second. In the similar way, when you calculate for system 2 settling time, again same formula, 4 divided by zeta value is 0.342 multiplied with omega n is equal to 1. This value is 11.69 second. Okay. Therefore, by seeing these two numericals, we can conclude settling time of system 2 is more than that of settling time of system 1. Okay. So, this is the answer. Now, let us look into question number 2. This is came from 1 mark exam. So, one block diagram is given. We need to find out what is the overall transfer function of the system. So, here in a simple terms, you can find the transfer function by using SFG concept, signal flow graph concept. Therefore, first let us look into forward paths. So, forward paths M1 is equal to, now here there is a minus sign. Because of the minus sign, the forward path gain will be minus G of S, and delta 1 is equal to 1 minus, you should take any loop gain that is not part of the first forward path. You don't have such combination, and hence it will be simply 1. Next one, individual loops. Individual loops. So, individual loops L11 is equal to, so this is one loop, hence I can take G of S, and L12 second individual loop, that is another loop in that way. So, that is minus G of S multiplied with minus 1. This will give you G of S. Therefore, delta is equal to 1 minus L11 plus L12. This is equal to 1 minus 2 into G of S. 1 minus 2 into G of S. Therefore, the overall transfer function of the system C of S divided by R of S is equal to M1 delta 1 divided by delta. This will give you minus G of S divided by 1 minus 2 into G of S, and hence option A is the correct answer. Now, let us go to next question. This question is from time response analysis. Consider the cascaded system as shown in the figure, neglecting the faster component of the transient response. Which one of the following options is a first order pole only approximation such that the steady state values of the unit step responses of the original and the approximated systems are same? So, out of these 4 options, one approximation will be approximately the time, the step response of the given system. Now, if you see the pole 0 locations of the overall system, the overall given system, you can notice that there is one pole at minus 1 and another pole is at minus 20 and there is a 0 at minus 40. This is the pole 0 diagram. Now in this case a pole that is much deeper into left hand side of the S plane, now neglect this pole. Okay, this is a concept of dominance concept, neglect this pole. Therefore the overall transfer function you can say it is approximately equal to k divided by S plus 1. This is a k divided by S plus 1. But what is k here, where k is equal to DC gain? So that will be limit S tends to 0, S plus 40 divided by S plus 20. So this will give you 40 by 20 is equal to 2. Therefore the required transfer function is equal to 2 divided by S plus 1 and hence option A is satisfying the given answer. Next, question number 4. Now here consider the stable closed loop system shown in the figure. The asymptotic body magnitude plot of G of S has a constant slope of minus 20 dB per decade at least till 100 radian per second, with the gain crossover frequency being 10 radian per second. The asymptotic phase plot remains constant at minus 90 degree at least till omega is equal to 10 radian per second. The steady state error of the closed loop system for a unit ramp input is. Okay, now in this problem, if you understand carefully the given statement, what is mentioned that the magnitude plot, let me take dB on y axis, frequency on x axis. The asymptotic magnitude Bode plot G of S has a constant slope of minus 20 dB per decade at least till 100 radian per second. Okay, so that means initially the slope is minus 20 dB per decade, at least omega is equal to 100 radian per second. After that we don't know what is the slope, and it is also mentioned that the gain crossover frequency being 10 radian per second. What do you mean by gain crossover frequency? The frequency where magnitude plot is crossing 0 dB line. So that is given 10 radian per second. Okay. Now the question is, what is the steady state error? So by seeing here the initial slope of minus 20 dB per decade, you can say that the given system is type 1 system. The given system is a type 1 system. So in this transfer function, G of S has the structure of k by s into some factors. So wherever this initial slope line crosses x axis or 0 dB line, that will be k value. So k is equal to, from this problem we can say that 20 radian per second. Why? Because in the initial slope I can say here G of j omega is equal to 1. So that will give you k by omega magnitude is equal to 1, and hence k is equal to omega. So that omega is given as a 10 radian per second. Now so this k, you can also consider that kV, static error constant. Okay, why? Because kV is simply nothing but limit s tends to 0, s into G of s. So that s will cancel out and finally you will be remaining with the kV is equal to k. Now under this condition, what is the steady state error of the ramp function, unit ramp function? So that value will be 1 by kV, as k is equal to 10, 1 by kV value will be 0.1. So for this question the correct answer will be 0.1, and as per the official key, any number you enter between 0.09 to 0.11. This range is considered as a correct answer. Okay, let us move to the next question. Consider the closed loop system with g of s is equal to k into s square minus 2s plus 2 divided by s square plus 2s plus 5. The root locus for the closed loop system is to be drawn for 0 less than or equal to k less than or equal to infinity. The angle of departure, you have to take the value between 0 and 360 degree. The angle of departure of the root locus branch from the pole -1 plus j2 in degree. Now, from the given transfer function, the first step what you can understand or you can calculate, where are the open loop poles. So, open loop pole locations are -1 plus or minus j2, and open loop zeros, they are located at +1 plus or minus j1. Okay. Now, with this, I prepared a slide to show you quickly the pole zero diagram for this given system. So, the pole zero diagram will be something like this. Okay. So, 1 0 is at 1 plus or minus j1. So, plus j1, another is a minus j1, and the poles are located at -1 plus or minus j2. Therefore, if you consider a point epsilon is very closer to root locus diagram, and the root locus diagram is leaving in this direction, then how can you find angle of departure? By simply applying angle criterion. So, how to write down that angle criterion? I can say here, by angle criterion, you can take minus theta 1 plus theta 2 plus theta 3 minus theta 4 is equal to odd multiple of 180 degree because of the negative feedback system. So, the 0 contributes positive angle, pole contributes negative angle. Therefore, if you substitute these angles, minus theta 1, now what is theta 2? 90 degree plus tan inverse. Now, here opposite side is 2 by 1 plus theta 3 is 90 degree plus tan inverse, opposite side is 2 and adjacent side is 3, and minus theta 4 is 90 degree is equal to 180 degree. Therefore, minus theta 1, we can cancel 190 here, and minus theta 1 plus 90 degree plus this value is tan inverse 2 is 63.43 degree plus 33.7 degree is equal to 180. Therefore, from this you can calculate theta 1 is equal to 7.13 degree 7.13 degree. But the correct answer range as per the official key, any number you enter between 4 to 8 can be considered as the correct answer. This is the root locus question. So, nicely given question. Next one, due to space adjustment, I splitted the question like this. Consider the stable closed loop system shown in the figure. The magnitude and phase values of the frequency response of G of S. Now, follow carefully. This is the frequency response of G of S. Okay, not complete forward transfer function. Next, given in the table, what is the value of gain Ki for a phase margin of 50 degree? Now, what I can do here, first let us find or let us write down the definition for phase margin. So what is the phase margin definition? 180 degree plus phase angle of the forward transfer function at gain crossover frequency. Therefore, that will be minus 90 degree plus phase angle of g of j omega gc is equal to 50 degree. Okay, because of denominator s, it will contribute a phase angle of minus 90 degree. Therefore, phase angle of g of j omega gc is equal to minus 40 degree. Okay, minus 40 degree. Now, if you look into the table, corresponds to minus 40 degree, the frequency is 0.5 radian per second. Okay, and corresponding omega, that is called gain crossover frequency, 0.5 radian per second. 0.5 radian per second. Now, but what is the definition? But at omega is equal to omega gc, the gain of the forward transfer function is equal to 1, absolute values. Okay, therefore, how can I write down here? Magnitude of k into g of j omega gc, okay, g of j omega gc divided by omega gc is equal to 1, right? Therefore, k, now this is basically ki, so ki into plus 20 log of g of j omega gc minus 20 log omega gc is equal to 0 decibel. Okay, therefore ki plus at what is this value? At omega is equal to 0.5 radian per second, the magnitude of g of s is given as minus 7 dB, okay, minus 20 log omega gc value is 0.5 is equal to 0. So, from this, by solving ki value, it will give you 1.12. By solving this, you will get ki value is equal to 1.12. Answer is 1.12, but the accepted range, the number anywhere you enter between 1.11 to 1.13 can be considered as the correct answer for this question. Okay, so these are the questions given in from the control systems subject in GATE 2024 electrical paper. So with this, I will conclude this video. I am Shankar, working as a faculty at Home Institute, Hyderabad. I will deal two subjects. One is power electronics, which is for purely electrical students, and control systems, it is for EEE, EC and instrumentation branches. So with this, I will conclude. If you are interested in GATE or AA coaching, you can call the number showing on this slide, or you can visit our website homeinstitute.com. Thank you. Thank you for watching. Hello everyone, I am Shankar. In this video, I would like to discuss the detailed solutions of control systems questions given in GATE 2024 paper, and this is from instrumentation paper. Now, the first question is, this is 1 mark question. In my lectures, it is from chapter 4, frequency response chapter. The sinusoidal transfer function corresponding to the polar plot shown in the figure for t greater than 0 is. Now, if you just recollect the polar plot of, suppose g of s is equal to 1 plus ts. So, for this particular transfer function, the polar plot can be when omega is equal to 0, the real part is 1. When omega is increasing from 0 to infinity, the polar plot will move in vertically upward. In the similar way, the real part is the same 1. When the frequency is increasing towards infinity, the plot will come down to bottom. This could be the transfer function for 1 minus j omega t. Therefore, option C will be the correct answer for the question. Now, let us move to next question. This is also one mark question. It is a little bit lengthy. Consider the state space representation of a system x dot is equal to ax plus bu, where x is state vector, u is the input. A is the system matrix and B is the input matrix. This is a common statement. Choose the matrix A from the following options such that the system has pole at the origin. Therefore, now from the state space equations, how can you find system poles? Poles is equal to roots of characteristic equation. What is characteristic equation? Si minus A is equal to 0. So here you should select one characteristic equation in such, you should select one system matrix A in such a way that the characteristic equation has a roots, at least one root at origin. Okay. Now, suppose for option A, if I check Si minus A determinant, you will get S minus 1 minus 1.5. I hope you can follow this 2 by 2 matrix, minus 2 and S plus 3 is equal to 0. Okay. Therefore, it will give you S square plus minus 2s or plus 2s minus 6. Okay. Plus 2s, it will be minus 3 and a minus 3. So, it will give you minus 6 is equal to 0. The roots of these characteristic equation 1.645 and minus 3.645. Okay. So, in these roots, there is no pole at the origin. Next, for option B, if you check Si minus A determinant, this will come around S minus 1, 2 and S minus 3 is equal to 0. Okay. Then what is the equation you have? S square minus 3s plus 3 is equal to 0. And for this equation, the roots of this characteristic equation are this will be minus 3 plus 2. So, it will be plus 2, I guess. So, this is a plus 2. Therefore, the roots are 1 comma 2. Next. So, here also there is no pole at the origin. Next one. For option C, by checking determinant Si minus A, what you will get? S minus 1, 1.5, 2, S minus 3 is equal to 0. Okay. Then it will give you S square minus 4s plus 3 minus 3. Hence, 3 cancel is equal to 0. Then the roots will be S is equal to 0 and 2. S is S square or S minus 4. Okay. 0 and 4. Right. Therefore, in this case, there is a pole at the origin. We got the required answer. So, you need not to go for option D because it is a simply MCQ. Only one answer will be correct answer. Next, let us move to the next question. This question is from time response analysis chapter. Consider a feedback control system shown in the figure. The steady state error is defined as ESS is equal to limit t tends to infinity r of t minus y of t due to unit step reference r of t is. So, what is the question here? you should find out steady state error for unit step input. So what is mentioned? So first let us find out what is the closed loop transfer function y of s divided by r of s, that is 1 by s into s plus 1 divided by 1 plus k by s into s plus 1. Now in this case 1 by s square plus s plus k, therefore then y of s is equal to r of s divided by s square plus s plus k. Now what is steady state error definition given? Limit t tends to infinity r of t minus y of t. Okay, therefore in the Laplace domain or S domain, how can you write this? Limit s tends to 0 by using final value theorem, s into r of s minus y of s. This will be limit s tends to 0, s into r of s, it is given unit step reference, therefore r of s will be 1 by s minus s into r of s is 1 by s divided by s square plus s plus k. So you can cancel this s here, then it will be remaining with 1 minus 1 by k, therefore k minus 1 divided by k, k minus 1 divided by k. That is the answer for question 3, option A. Next one, another 2 marks question. Consider a unity negative feedback system with its open loop pole 0 map as shown in the figure. If the point s is equal to j alpha, where alpha is greater than 0, lies on the root locus, then the value of alpha is. Now this problem is from stability chapter, that is a third chapter in my lectures. By using Routh's method you can find out. Now from the given open loop plot, we can define the transfer function, open loop transfer function as, because negative feedback system means open loop transfer function and forward transfer function both are same. Therefore it can be k by s into s plus 1 into s plus 4. This is the open loop transfer function. Next, what is characteristic equation? Characteristic equation is 1 plus g of s is equal to 0, then it will be s into s square plus 5s plus 4 plus k is equal to 0, or s cube plus 5s square plus 4s plus k is equal to 0. Okay, then what you have to do, let us define Routh's table. Let us define Routh's table. So s cube elements 1 and 4, s square elements 5 and k, s power 1 elements 20 minus k divided by 5, and s power 0 element, it is k. Now in order to have this root locus diagram located on j omega axis, there should be even polynomial as a common factor. So that is possible when you have row of 0 appeared at s power 1. This is true when k is equal to 20. In that case, auxiliary equation can be 5s square plus k is equal to 0, or 5s square plus 20 is equal to 0, then s square is equal to minus 4, or s is equal to plus or minus j2. So it is mentioned that alpha value is greater than 0, therefore alpha is equal to 2 here. Okay, because it is mentioned S is equal to J alpha is on the root locus diagram, and hence alpha value is equal to 2. 2 is the answer for the question. Now let us look into next question. It's a very easy question, even though I don't know why it is given for 2 marks. The transfer function of a system is G of S is equal to omega n square divided by S square plus 2 zeta omega n S plus omega n square. Choose the range of zeta and omega n from the following options such that the poles lie on the shaded region of S plane as shown in the figure. Now the only twist in this problem is this angle is given 120 degree, therefore you have to take this angle theta. So zeta is equal to cos theta. When this angle is 120 degree, theta will be 60 degree, therefore zeta is equal to 1 by 2. Next, in the shaded region, theta is less than 60 degree, hence damping ratio could be greater than, of course, or equal to 1 by 2. Okay, so in the shaded region you can take it like this: theta is less than or equal to 60 degree, hence zeta is greater than or equal to 1 by 2, and this particular phasor distance will be omega n is equal to 2. Therefore in the shaded region omega n definitely greater than 2, and hence option B is the correct answer. So these are the questions. I hope total 8 marks came from this instrumentation paper, control system subject. So these are the questions from GATE 2024 control systems instrumentation paper. So I'm working as a faculty at Home Institute. We will offer coachings for GATE as well as AE exams for various PSUs. If you are interested, you can visit our website or call the phone number given on this slide. Thank you for watching, and if you not yet subscribed my YouTube channel, please subscribe and spread a word with your friends and other relatives also. My YouTube channel is for purely educational purpose. Thank you for watching.